We're on lesson 3 of chapter 9, which is the area of irregular figures. First, we're going to estimate the area of an irregular figure. Then we're going to find the area of a composite figure. Then we're going to solve a real-world application. The vocab word for this section is a composite figure, which could also be an irregular figure. A composite figure is a figure made up of simple geometric shapes, and then they're combined together to make one shape. So for example, we have this shape here. If you notice, you could draw a line from here to here, and from here to here, and show that it would be 3 different rectangles, or 2 rectangles and a square, all combined into one shape. Doing that, you actually could find the area of that. For example, this rectangle is 2 centimeters by 4 centimeters. Length times width is the area of a rectangle, so this would be 8. Now what's the height of this area? You might say 5, but 5 is actually the entire area for here. So below this line would be 5 minus this part, which is 2. So this is actually 3 centimeters. 3 times 9 is 27 centimeters. Then we're left with this part, which is 3 centimeters by 3 centimeters. 3 times 3 is 9. So we'd add up all these parts. 27 plus 9 plus 8, that all equals 44. So this is actually 44 centimeters squared for this whole figure. Our first problem is to estimate the area of an irregular figure. So it tells us to estimate the area of the figure. Each square represents 1 foot squared. If you notice, sometimes we have whole squares that are filled in by this figure, and sometimes we don't. The best way for us to solve this would be to count. First, we can estimate by counting the whole squares. Then we can figure out the area of the half squares and add them on. So in this row, I have 8 whole squares. This row also has 8. Even though this one's not quite whole, I'm going to count it as a whole square. This one then has 7 whole squares. This has 6. This has 3, 2, and 1. So if we add all the whole squares together, that would be 16, 23, 29, 32, 34, 35. So 35 whole squares. Then we have 1, 2, 3, 4, 5, 6 half squares. So 6 times 1 half would be 3. So our half squares combine to make about 3 whole squares. So if we do 35 plus 3, that would give us a total of about 38 whole squares. So we would say for our answer, 38 feet squared. That would be an estimated guess. It's not going to be exactly 38 feet squared, but it'll be pretty close to that answer. Now we can find the area of a composite figure. So it tells us to find the area of each figure, and if we need to, use 3.14 for pi. For this figure, they actually already drew the lines in for us. For example, we have a triangle here, we have a rectangle here, and we have a half circle up here. First, we could find the area of the easy one, the rectangle. I can't use this measure because that measures the whole bottom. This measures the top, however, of the rectangle. So this would be the width of the rectangle, and this would be the length of the rectangle. Length times width is 24. So this rectangle here is 24. Now let's find the area of this triangle. I see that this measure of the triangle is 2 meters, but this one it doesn't tell me. Well, it tells me this whole area is 7, and this on top is 4. So if this part is 4, and this whole thing is 7, what would this be to make the whole thing 7? Well, that would be 3 then. 3 plus 4 is 7. Now I can find the area of a triangle. The area of a triangle is length times width divided by 2. So we do 3 times 2 divided by 2. So we do 3 times 2, which is 6, divided by 2 is 3. So the area of this triangle would be 3. What I'm going to do is I'm going to treat this like a whole, and I'm going to divide it in half when I'm done. So since this is a diameter of 4, I can find half of that to find the radius, which means this will be a radius of 2. Like we learned in our last lesson, the formula of a circle is pi times radius squared. 2 squared would be 4, so pi times 4. Pi times 4 equals 12.56. Remember, we only need to find half that circle. So we can multiply this times 1 half. So when we do that, that would give me 6.28. Now that I've found the area of the rectangle, the triangle, and the circle, I can add all them together. 24 plus 3 plus 6.28. That'll give me an answer of 33.28, and I'll say that's in meters squared. So this is the area of the entire figure. With this one, they did not give us all the dividing yet that we need to do. And there's a couple different ways that we could do this. I can either make a figure like this, or I can make two rectangles like this. Why don't we make another figure like this? So now I have a rectangle, I have another rectangle, then I have this little triangle at the end. Well, this first rectangle will be pretty simple. It's 10 feet by 8 feet. Length times width is 80 then. 10 times 8. This one will take a little bit more work. This one is 4 feet all the way across. How about up and down? Well, I see that this whole part is 10, and this part going down to this rectangle is 6. So 6 plus what? 6 plus x equals 10. Well, that would have to be 4. So I know that this dimension is also 4. That means that this is a square. 4 times 4, length times width, is 16. Since this line was 4, this line is actually 4 as well. So we could write that in there. How about this little line on the bottom for this triangle? Well, I see that this whole part is 14. From this point all the way over here is going to be 4 plus 8, which means 12. So this adds 2 to that 12 by making it 14, meaning that this part is 2. So the area of a triangle is length times width divided by 2. So 4 times 2 is 8, divided by 2 is 4. So I found the area of this rectangle plus the area of the square, now the area of the triangle. Add those together to get our full area. 80 plus 16 plus 4, that's going to give us an answer of 100. And we're going to answer that in feet squared. Now we can do a real-world application. It says the figure shows the dimensions of a room in which wedding receptions are held. The room is being carpeted. The 3 semicircular parts of the room are congruent. How much carpet is needed then? Well, I notice that the easy part of this is going to be solving for the rectangle. That's just the length times the width. So 18 times 12 gives me an area of 216. Now this part will take a little bit more work. I notice I have 3 half circles. So what I want to do is I want to solve for a whole circle. Then I want to divide it in half because it's only half of one. Then I want to multiply times 3 because there's 3 exactly the same. What is the diameter of one of these? Well, I notice that there's 3 that go all the way across. So if I'm going to find the diameter of this semicircle, it's going to be 18 divided by 3 because 3 go into the 18. So each diameter would be 18 divided by 3, which is 6. So this is a diameter of 6, and that has a diameter of 6. So we can use the formula of area equals pi times radius squared. So first we need to find the radius. Well, if the diameter is 6, the radius then would be 3. So pi times 3 squared. 3 squared equals 9, so pi times 9 equals our area. Pi times 9 equals 28.26. So I have found the area of one circle. Remember though, this is a half of a circle. So we need to multiply this times 1/2. That gives us an answer of 14.13. So now that we have found 1/2, we can multiply that times 3 halves. So we can multiply that 14.13 times 3. That gives us an answer of 42.39. So this is the area of the half circle. This is the area of the rectangle. If I add that together, that gives me an answer of 258.39. And that's going to be in meters squared. So for this figure, I found the area of the rectangle. I found the diameter because it was 18 divided by 3. Found the radius. Used that to find the area of a whole circle. Divided that by 2 because it's half of a circle. Then multiplied that times 3 because there's 3 half circles. Adding the area of the circle with the area of the rectangle gave me 258.39 meters squared.